So when I say data analysis, what's the first thing that pops into your head? Spreadsheets? Complex math? Well, what if I told you it's actually a lot more like a crime scene investigation? That's what we're cracking open today. Because data isn't just a bunch of numbers, it's a collection of clues. And your job? Well, it's to be the detective.
You know, every single data set out there tells a story. It might be about what customers are buying, or a new scientific breakthrough, or maybe even a hidden trend in the market. But that story, it's usually locked away, right there in plain sight. So to uncover it, you've got to trade in that calculator for a magnifying glass and start thinking like a modern-day Sherlock Holmes, piecing together the evidence to see what's really going on.
All right, so where does any good detective start? Not by shouting, "I've solved it," right? No, they begin by quietly surveying the scene. And this first step is maybe the most important of all, getting a feel for the clues. In our world, that means getting a feel for the data before we even think about jumping to conclusions. And this part is absolutely crucial. Before you run any fancy analysis, you have to just look. It's kind of like walking into a room, taking a deep breath, and just observing. What's here? What's missing? Does anything feel a little out of place? Taking this moment stops you from chasing bad leads and really helps you build an intuition for the entire case. So we can break this whole intuition thing down into 3 really simple steps. First up is the first glance. You're just scanning the raw information, no judgment. Next, you identify the usual suspects. This is where you find the average or the most common values to get a baseline. And finally, you create the lineup, a chart or a graph, so you can actually see the data's overall shape and spot anyone or anything that just doesn't seem to fit in. Okay, once you have a feel for the scene, the next move is to examine the shape of the evidence. You're looking for patterns in how it's all structured because, trust me, this is where the most fascinating clues usually start to pop out. A lot of the time, you'll find a pretty common pattern called normality. Think of this as your baseline, the straightforward case where everything seems to be in order. It's the story you'd expect to find, with most of the evidence pointing right to the most obvious conclusion there in the middle, and fewer clues way out on the fringes. And this chart illustrates it perfectly. See that big, tall bar right in the center? That's your average, where most of the clues are all clustered together. Then, notice how it tapers off symmetrically on both sides. This balanced, bell-like shape, that's the classic sign of a normal distribution. It's clean, it's predictable, it's normal. But this is where the plot really thickens. What happens when the evidence doesn't line up so neatly? You know, what if the pattern feels unbalanced, maybe a little lopsided? This is the exact moment when a great detective's instincts start firing. An unusual pattern isn't a problem, it's a major clue. We call this a skewed distribution. As you can see, unlike that perfectly symmetrical, normal shape, this pattern is getting pulled off in one direction. But why? Well, it's often because of an outlier, some powerful force that's warping the whole story. Imagine you're analyzing average income, and a billionaire happens to be in your sample. Suddenly, the whole picture gets skewed, right? That skew is your clue. It's telling you that this simple average is actually misleading, and something or someone is having a really big influence. And now for what feels like the real magic trick of data analysis. See, real detectives rarely have all the evidence. They usually solve the entire case based on just a few powerful clues. And in data, we do the exact same thing. This is the big leap, going from just a small sample to the whole story. And this analogy is just perfect. You don't have to drink an entire pot of soup to know if it needs more salt, do you? Of course not. You just need one well-stirred spoonful. Data analysis works the same way. A small but really well-chosen sample can tell you an incredibly credible story about a much, much larger group. The official term for this is inferential data analysis. It's basically the science of making smart, educated guesses. By analyzing that one spoonful, that single sample, we can infer what's going on in the whole pot. This is exactly how we do things like political polls, test new medicines, and understand huge populations without having to talk to every single person. So why did we go through all of this? Why does learning to think like a data detective actually matter in the real world? Well, it's because these fundamental skills are what turn raw, totally meaningless numbers into actual insight, action, and ultimately solutions. So let's recap the detective's toolkit we just put together. First, you start by getting a feel for the data to survey the whole scene. Then you identify normalities so you understand the expected story.
You learn to spot skewness as a critical clue that something unusual is happening. And finally, you use inference to take that tiny clue and solve the entire mystery. So, the next time you see a statistic, a chart, or even just a spreadsheet, please don't just see numbers. See it for what it really is, a mystery that's packed with clues. You have the tools now. The only question left is, what stories are you gonna uncover? Go find them.